but
those aren't that bad, those problems.
you're good with these kind of problems?
Yeah.
You sure?
Yeah.
I'm reading each of these and they look fairly straightforward. Let me just make sure. You didn't do the 45 right. Here, let's just go over 45. Notice what the formula is on 45. Because we're compounding monthly, so it really should be A is equal to the starting principal times 1 plus 0.04 over 12, the number of times per year we're compounding, but then it's to the nt. It's not to the 6th power, it's to the 12 times 6, the 72nd power. Okay? And then the rest of it, you're just going to do that in your calculator. In other words, this is not the easiest thing to do in a calculator, but do you have an Inspire?
I have, Texas Instruments, like TI-84.
Okay, well, it's a little tougher to put these into that because you got to use a lot of parentheses and everything. So the way I'm going to suggest you, it's real easy to make a mistake if you get your parentheses wrong. So the way I would solve this in your calculator is I would solve that number first. Then I would take it to the 72nd power, get that number, and then I would multiply it by 5,000. That's the way to do it. Now, it looks like this can't be right, correct? How can we have a 72nd power? But trust me, it is. What is going to happen here is this number is going to be very small. That number is going to be like 1.003. So I'm taking a number that's very close to 1 to the 72nd power. It's not going to be as big as you think. It's going to maybe be 2 if it gets that high. In fact, I'll bet it's not 2. You have your calculator in front of you?
Yeah.
Go ahead and do it. Let's just get the right answer on here because the one you've got up here isn't going to be correct. And then take your answer and multiply it by 5,000. What do you get? Yeah, see, you're only getting 6 months of interest the way you did it because you took it to the 6th power instead of the 72nd power. That would be what you would take it to if you were only leaving it on deposit for 6 months. That's why you got such a small amount. You didn't make much interest on your answer. You should make a lot more interest than that after 6 years. You should almost increase your money by a factor of 50%. So did you come up with an answer yet?
Yeah, I just think
So you got to do 1.003 raised, that's that, to the 72nd, all times 5,000. And it's not 0.003, it's whatever 0.04 divided by 12 is. Add it to 1. So actually, this isn't, I don't want you to do this because I forgot I was giving an approximation when I said 1.003. It's not quite 0.003, it's more like 0.003 with a remainder of 4, so it's that.
it keeps on giving me 0.
For which part?
When I I take it to 0.003333. It must be 1.0.
It is. Do you see my 1?
Yeah, it's just like...
Here's what's happening. Here's what's happening. When you did this, and you took that to the 72nd power, it almost went to 0. In other words, every time you take a tiny number and you square it or cube it, it gets smaller. If I take a tiny number and I take it to the 72nd power, it gets near 0. So your calculator could not even distinguish it from 0. But if you put the 1 in front of it, like that, now it'll give you a number greater than 1. When you take a number greater than 1 to a power, it gets bigger.
Yeah. Yeah, I got it. It was just...
Now multiply that by 5,000. What do you get?
It's 6,353.71.
Okay, that's not a bad, I didn't quite get that number, but it's not important that I have it. So you made about $1,300 in interest. That's not bad. 4% is not the greatest rate. But still, it's going to, in other words, you can see that you're going to make at least $200 a year just at 0.04. The very first year I'm going to make $200 if they compounded it yearly. So you know this is not a ballpark answer. The answer you put down there is not even in the ballpark. And you should get in the habit of checking that when you do these problems. Make sure your answer makes some sense.
Would we be able to go to problem 69?
Sure. It's the conversion factor going from radians to degrees. What's that?
It repeats 69 for some reason. It's like the next 69. Not that one.
Okay.
Like, see, after like 76, there's another 69.
Yes, I do. And I assume these are all 7 pi over 4? In other words, he couldn't print the pi?
Yeah. I was thinking, I don't know, it's asking, put that in degrees, right? Or is it...
No. It's asking you to come up with what is 7 pi over 4 and what's the sine of that. And this is an exercise that we've done multiple times, and you need to be able to do this. Only because look at how many problems there are. There's 8. If you can figure out how to do one of them, you're going to be able to do 8 of them. If you can't figure out how to do one of them, you're going to get all 8 wrong.
Sine equals y. Right? Sine equals y.
No. We're going to do the sine of 7 pi over 4.
Okay.
What quadrant is that in? Now, here's something you can do, which is fine. If these give you problem working in radians, then convert it to degrees, and we'll do everything in degrees. It's going to give you the same answers. It's just, I suspect that you're going to be better off working in degrees. So multiply that thing by 100. I don't know, is that true or false?
It's true.
Okay. So let's multiply it by the conversion factor, which is 180 over pi. What do you get? What's 7 pi over 4 times 180 over pi?
So, like, I get a cheat sheet on this test, like the card.
You don't want a cheat sheet on this, Sam. Trust me, you do not want a cheat sheet on this. Unless your cheat sheet is the drawing of the unit circle that I've drawn for you many times.
Yeah, that's what I was going to do.
Okay, all right. Let's talk about a cheat sheet. Seriously, let's leave this for a moment. Let me put up my thing, and let me show you what you want on your cheat sheet.
Okay.
Precisely what you want. First of all, at the very top, do you need SOHCAHTOA, or you got that down pat?
No, I don't.
Okay. Let's draw the unit circle. Label the quadrants.
Yeah, you should just, the cheat sheet will be.
In the second quadrant, you're going to use 180 minus theta. In the third quadrant, you're going to use theta minus 180. And in the fourth quadrant, you're going to use 360 minus theta. Make sure this information's on your cheat sheet. These will give you the reference angles. Also, all students take calculus. You know what those four letters mean, right?
No.
The A means all 6 trig functions are positive in the first quadrant. The S means in the second quadrant, only sine is positive. And, of course, it's reciprocal. What's the reciprocal of sine?
Cosecant.
Okay. So sine and cosecant in the second. In the third quadrant, what's the T mean?
Tangent.
That's the only thing that's positive in the third, is the tangent and, of course, the cotangent. You can't have the reciprocal being positive without its reciprocal also being positive. And in the fourth, what's the only thing that's positive?
Cosine.
So all students take calculus will tell you the plus or minus sign on every trig function that's in that quadrant.
And that means it's plus all those or minus?
No? Yes. Anything that, in other words, okay, let's test. What is cosine in the fourth quadrant? Plus or minus?
It's negative.
No, it's positive. According to this means it's plus.
Oh.
What's cosine in the second quadrant?
Cosine in the second quadrant is negative.
What's cosine in the third quadrant?
It's positive.
No, it's negative. If it didn't say it's positive, then it's negative. In other words, the only ones that are positive are sine in the second, tangent in the third, and cosine in the fourth. That's what those letters mean. It means that if I'm in the cosine and I'm in the second, I'm negative. If I'm cosine and I'm in the third, I'm negative. If I'm tangent in the fourth, I'm negative. If I'm tangent in the second, I'm negative. The only ones that are going to be positive are sine in the second, tangent in the third, cosine in the fourth. Plus, their reciprocals have the same plus or minus sign as they do. So technically, this should be underneath the S should be cosecant. And underneath the T should be cotangent, and underneath the C should be secant, but notice that doesn't fit any nice little anagram. In other words, you can no longer say all students take calculus. So they leave off the bottom one and leave it to you to make sure that you realize that if the cosine is positive, then so is the secant.
Okay.
Okay? Now,
Can we look at those triangles you always drew?
yes, I'm going to do that. That's coming. These are key. And the key is the dimensions of them. And one is a 30-60-90, and the other is a 45-45-90. And these dimensions will now allow you to figure out the sine and cosine of any first quadrant angle. For example, what is the tangent of 45 degrees? 45. They're not going to ask you about 35-degree angles. They're going to, all of these questions, those 8 questions we were about to do, they are all multiples of 30, 45, or 60. Trust me. Those are the only ones they ever ask about.
Wouldn't it just be one?
Yes. What is the tangent of 30 degrees?
Tangent of 30.
Uh-huh.
Tangent of 30 is, it's 1 over root 3.
Good. Don't worry about rationalizing. When I say rationalize, you know what I'm talking about, right?
Yeah.
Okay. It's just that the new trend in trig is to not rationalize stuff. Whether your teacher will accept that or not, I don't know. Only you know that. But I love it when trig is taught where you don't rationalize anything. Can you see that you can get all 6 trig functions of 30, 45, and 60 from these 2 triangles?
Yeah.
Okay. If you can figure out the first quadrant angles for all 6, then figuring out the second, third, and fourth is a piece of cake. Okay, so let's go back to that problem. 7 pi over 4. First thing we did is convert it to degrees. That gave us 315 degrees. Okay? What quadrant are we in?
My bad, I was writing this down on the cheat sheet.
Well, you shouldn't. What you should do is take a picture of this after I'm done with it. 'Cause I'm not quite done with it yet. I'll tell you when to take a picture of it. And then you won't need a cheat sheet, you just need your phone.
Okay.
Okay? But let's go back and do this problem. I'm going to erase this before I have you take a picture of it on the left here. It's just an example of how we're going to do it. So the first step after you've converted it to degrees is figure out what quadrant are we in.
We're in 4th quadrant.
What is its reference angle, which I'm going to put in parentheses right here. You get the reference angle from that formula that's in that box in the 4th quadrant.
Yeah, it's 45.
Okay, so I'm going to write 45 there. And now, what's the sine of 45 degrees based on this triangle over here?
It's 1 over root 2.
And finally, the last step is what is its plus or minus sign? Is it positive or negative?
Negative.
Correct, because it's sine. Only cosine is positive in the 4th. That's the way we're going to do every single one of those problems. We're going to convert it to degrees. We're going to figure out its reference angle based on this picture over here. And then we're going to put its plus or minus sign based on this picture over here. So it's very specific steps. Don't want to do anything different. Just do that exact process on all of it. So, that right there, you sure you don't want me to write SOHCAHTOA up here?
No, it's fine. I know how to do that.
I'm going to put it there anyway, because all you're going to do is take a picture with your camera, and everything's going to show up on it. So, let me think of what else needs to be on here.
I don't know. That's whatever you
I know what needs to be on there. The quadrangles.
The what?
The quadrangles. Let me draw a unit circle on here. I'll tell you, once I label it, you'll remember why it needs to be on here. That's a unit circle, okay? What's that point right there?
Is that pi?
No? What point is it in the XY coordinate system? 1 comma 0. Now, the x-coordinate happens to be the cosine of theta. The y-coordinate is the sine of theta. So if I said to you, what is the cosine of 0 degrees, what would the answer be?
1.
What's the sine of 0 degrees?
0.
Okay, now let's go up to this point. That's going to represent a 90-degree angle. What are the coordinates of that point?
It's going to be 0, 1.
What is the cosine of 90 degrees?
0.
What's the sine of 90 degrees?
1.
You see how valuable this is going to be?
Yeah.
Okay, so let's put this point. That's minus 1 comma 0. And this point down here. Now you got everything you need to do every single angle they're going to expect you to do without a calculator.
Okay.
And that's it. Take a picture of that.
Well, what about the ones that are, I guess you could just...
They're not going to, yeah. In other words, you're right. If I had a 45-degree angle here, then the coordinates at that point are going to be the cosine of 45, comma the sine of 45. But you can get those numbers from these two triangles. Notice what you cannot get from those two triangles. You cannot get your quadrangles. I can't figure out from these two triangles what the sine of 90 degrees is, or the sine of 180, or the tangent of 180. They're not helpful. They're only going to help me solve 30, 45, and 60 degree angles. So the quadrangles are different. You're not going to use this. Now there is maybe one other thing you want. I certainly would want it. And that's the shape of a sine curve and the key points on it. Goes up to 1, goes down to minus 1, and it goes out to 360 degrees. That's its period. That is y equals sine of x. And you can also get your quadrangles off of this. Clearly, the sine of 0 is 0, right?
Yeah.
Now, let me put the cosine curve on there, and that'll complete it. Cosine curve also goes out to 360, also goes up to 1 and down to minus 1, and looks like that. Let's label that y equal cosine of x. Now if you take a picture, you're in like Flint. Everything that you would need to answer most of those questions you can get if you have this page. Now, can I erase the 1, 2, 3, and 4?
Yeah, you can...
Because I don't want any information on here that you don't need. It's just confusing. You know the quadrants, right?
Yeah.
Okay, so I'm going to erase the 1, the 2, the 3, and the 4. Now you say you don't need SOHCAHTOA? Let's erase that. Let's put as little on here as necessary. But every single thing I see on there now is necessary. What do you suppose this point is on the x?
Huh?
I was about to. What do you suppose this point is on the x-axis of the sine curve?
Would that be pi?
Or 180. Yeah. I got no problem with you working in radians, but everything on this page is in degrees. Okay?
Yeah, I know. Yeah, I know, like pi and 2 pi.
You don't like that?
No, I know that.
Okay. 360 is the same as 2 pi. Pi is the same as 180. So if I really wanted to handle both degrees and radians, then I would also write here pi minus theta if you're in radians, or theta minus pi if you're in radians, or 2 pi minus theta if you're in radians. There, now you have for radians and or degrees. This point right there is halfway, so that's 180. This point where it reaches its peak is 90, halfway to there. In other words, and that's the same for both of these curves. These points are all key points. It's 90, 180, 270, 360. Same thing down here. This is 90, that's 180, that's 270, that's 360. And they are the 4 key points of those functions. And by that I mean they are the points where the function is either equal to 1, minus 1, or 0. So this page, in fact, why I got it up there, I'm going to take a picture of it. Because I've redrawn this thing so many times and I don't always remember exactly what the best thing to put on there is. So let me put it in my camera and then I won't have to think anymore next time I do it. Okay, I got it. This is going to be my new standard trig page. Alright. We're doing a half hour tonight or longer?
We can do like just a little bit longer. Can you go through my study guide? Tell me what I should have on my sheet. What's most important?
So what do you want to do next?
Let's just go through the study guide and you should tell me. Actually, go to the probability first. Which is in the front of the packet.
Okay.
Yeah,
I got it here. Okay, let me check your answers. There's a total of 20 sweaters. So 3 out of 20 is correct. Probability of choosing a black or yellow, well, there's 8 blacks and 4 yellows, so that's 12 over 20, which is the same as 3 over 5. Probability of not choosing a blue, well, there are 15 non-blue sweaters, so that's 15 over 20. These must be the ones you're having problems with, because you didn't have any problems with the previous one. Number 5. A card is selected from a standard deck of 52 cards. Probability of choosing a king or a queen, there's 4 kings, there's 4 queens, so 8 over 52. That needs reduced. It's 2 over 13 is what that reduces to. Probability of choosing a face card or a heart. Well, we got to figure out how many hearts there are and how many face cards there aren't hearts. We don't want to double count. So how many hearts are there?
4.
No, there's 13 actually. In other words, a deck has 4 suits and there's 52 cards. So there's 13 cards from every suit. Okay? So there's 13 hearts. But there's also a face card. God. I presume he means 10, jack, queen, or king, correct?
Yeah.
Okay. How many non-heart 10s are there?
Non-heart 10s.
There's 3 of them. There's the 10 of diamonds, the 10 of spades, and the 10 of clubs. Remember, there's only 4 suits. So there's going to be 3 non-heart 10s. There's going to be 3 non-heart jacks. There's going to be 3 non-heart queens. And there's going to be 3 non-heart kings. So this is how many hearts or face cards there are, which is 25. So 25 over 52 is the answer to that question. If I want to choose a face card or a heart, there are 25 of those in the deck. 25 exact cards that will fit the description. They're either a face card or a heart. So it's not 54 over 52, it's 25 over 52. And that cannot be reduced.
I think that the tens are not a face card.
Well, it kind of depends. If you're in Vegas, a 10 is a face card. I don't know what he means by a face card. He doesn't say. So you would know better than me. If 10s are not face cards, take off 3, and the answer is 22 over 52, which does simplify. It depends on whether 10s are considered face cards or not. In blackjack, a 10 is a face card. And I guess in just talking about a deck of cards, perhaps a 10 is not a face card. Maybe he means a paint. In other words, if you're in Vegas and you want to talk about jacks, queens, or kings, you call them paints, not face cards. Face cards include 10s. But paints, if you look at a deck of cards, a 10 doesn't have paint on it, whereas a jack does, a queen does, and a king does. So jacks, queens, and kings would be paints. And like I said, I don't know what he means here. Doesn't matter as long as you do. Okay? Now, let's look at the next one. Probability of choosing a club or a 2, 3, or a 4. Now this is more specific. How many clubs are there?
4.
13. Plus how many 2s that aren't clubs? Because I want to eliminate the ones that are clubs, because this 13 includes the 2 of clubs already. So I want to know how many other 2s there are that are not clubs. How many 2s are in a deck of cards?
There's 4.
Okay. There's only one of those 2s that's a club, so there's 3. There's the 2 of diamonds, the 2 of hearts, and the 2 of spades.
So then you just have 3 for...
That's the number of 3s. That's the number of 4s. That gives us 22. There's still 52 cards in the deck. That gives us 11 over 26. That's the answer. Okay. All right, you're rolling dice. You roll 2 dice. And all dice have, well, not all of them, but most dice have 6 sides on them with the numbers 1 through 6. Okay? And there are 36 possible outcomes. Why? Because the first dice can have 6 different numbers. The second dice can have 6 different numbers. Product of those are 36. In other words, I can have a 6 and a 1. I can have a 6 and a 2. I can have a 6 and a 3. I can have a 6 and a 4. I can have a 6 and a 5. I can have a 6 and a 6. So there are 6 combinations where one die has a 6 on it. Now, let's talk about the first die having a 5. There's going to be 6 combinations where that first die can have a 5 on it. And the second number can be a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 more ways where the first die can have a 5. So do you see why it's 6 times 6, the total possible combinations?
Yep.
Okay. Now, find the probability of rolling a sum greater than or equal to 9. Well, we know there's 36 possible combinations. Greater than or equal to 9. Well, one die is going to have at least a 3 on it, right? In other words, if one die has a 1 or a 2 on it, then there's no way that the sum can be greater than or equal to 9. So one die has to have at least a 3. That's greater than or equal to 9. 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 Might look like the same combination, but it's not. In other words, this combination, the first die has a 4, the second die has a 5. This down here, the first die has a 5, second die has a 4. 5, 5 works. 5, 6 works. 6, 3 works. 6, 4 works. 6, 5 works. And 6, 6 works. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are exactly 10 out of 36 ways to do that. And this is called a counting problem, which is a key thing for probability, is the ability to count out all of the ways that something can occur. And I did. I knew that there was no point in considering any die that had a 1 or a 2 on it. So I started with 3. And if one die's got a 3, the other one's got to have a 6. And then I went to 4. Well, now the other one can be 5 or 6. And 5 had 3 other possible numbers, and 6 actually had 4 combinations. So that's how you do that problem, is you count out each possible way. It's kind of like if I asked you, how many ways can 3 letters be arranged? Well, there's that way, and then there's that way, and that's the only 2 ways where A is the first letter. But what if B is the first letter? Now I can have an AC, or I could have a CA. That's the only 2 ways that B can be the first letter. And now the third 2 ways, I'm going to let C be the first letter. So CAB or CBA. That's it. There's only 6 ways that 3 letters can be arranged. And it's important that you be able to do this kind of exercise. Is, in other words, count out each way. And then you'll learn a general formula for doing it when it's so many letters that you can't do it manually. In other words, if I said how many ways can 12 letters be arranged, I'd still be, tomorrow, next week, I'd still be counting them out. So you're not going to do it as a counting problem when you get big numbers. But on small things, like how many ways can 3 letters be arranged, you want to be able to physically lay out all 6 ways in the way I've done it here. All right, let's do one more and then call it a night. The next one's pretty cool. I mean, not cool, but different. A little different. Because the next one involves not replacing the cards. So you pick 3 cards from a 52-card deck, and they want to know the probability of choosing 3 face cards. Well, that means the first card has to be a face card. How many face cards are there? If you don't count tens? In other words, if we count just jacks, queens, and kings, how many face cards are there? Okay, so the odds of getting a face card the first pick are 12 over 52. That has to happen. You also have to get it on the second pick. Well, how many remaining face cards are there? In other words, I picked a face card on the first pick, otherwise the problem's over. The only way the problem makes sense is if we did pick a face card on the first pick, so how many face cards are left for the second pick?
11.
How many cards are left in the deck?
51.
Now, we had to pick a face card on the first and second, so how many face cards are left on the third pick?
10 out of 50.
And multiply those together, and that's your answer.
Yeah, I just have a question.
Uh-huh.
If it says and, does that mean add the numbers?
If it says and, not always, no. In fact, and usually means you multiply.
I meant to say or.
Well, or means you add, usually. It's not quite that simple, but if I said, what's the probability of me flipping heads 3 times in a row? Well, I'm multiplying. The first time it's a half. Second time it's still a half. Third time it's still a half. Multiply all of those, you get 1 over 8. The odds are 1 out of 8 that I'm going to flip heads 3 times in a row. But if I said, what's the odds of me flipping a heads on any of the 3 draws, it's not quite 1/2 plus 1/2 plus 1/2. Notice that would give you 3 halves, and the maximum probability ever is 1. So, or doesn't necessarily mean add, but it means add more so than and does. And means everything has to happen, therefore you're multiplying. In other words, I have to get a face card on the first pick, I have to get a face card on the second pick, and I have to get a face card on the third pick. Since all 3 of them have to happen, I'm going to multiply those 3 numbers together. That gives me the probability of all 3 of them happening.
Okay.
Now, if it said with replacement, then it's 12 over 52 times 12 over 52 times 12 over 52. Because every time I draw, there's 12 face cards out of 52 in there. So whether we replace or not actually matters. This is much better chance, not much better, but slightly better chance than this is. All right. I've had 2 unbelievably long days, so Sam, I'm going to let you go.
Okay.
And talk to you next time. Good luck on your test tomorrow.
Okay, thank you.
So this might be the last time this year we work. If you're doing any math work this summer, think of me. I like to do a lot of tutoring in the summer. I reduce my rates. So if you have a need in the summer, then let's go for it.
Okay, sure.
Talk to you next time. Bye-bye.